This is the solution video for section 2.2, problem number 12. So problem number 12, find the x coordinates of all the points on the graph of y equals x to the 3/2 minus x to the 1/2, at which the tangent line is parallel to the line y equals x minus y minus x equals 3. All right, so first of all, y minus x equals 3. If we rewrite this as y equals x plus 3, we realize that the slope of this line is 1, right? Y equals 1x plus 3. So now, if the tangent line is to be parallel to this line, that means the slope of the tangent must be the same. So the slope of the tangent also equals 1. All right, so if I have y equals x to the 3/2 minus x to the 1/2, we need to find the derivative, because then the derivative can be set equal to the slope of the tangent. So y prime equals, all right, so if I have x to the 3/2, y prime would be 3/2 x to the 1/2 minus 1/2 x to the negative 1/2. All right, so that is the derivative. Now, we're going to set the derivative equal to 1, because that would tell us when the tangent line has the same slope as this line, y equals x plus 3. So I'm going to set this equal. All right, now I'm also going to rethink about this. X to the 1/2, that's actually root x. Then I have minus 1/2 x to the negative 1/2. That would actually be 1 over 2 root x, because x to the negative 1/2 puts the root x in the denominator. All right, so now this seems like a weird equation to solve. And it is, but what we're going to do is we're going to make it a little easier for ourselves. We're going to get rid of the denominator. So we're going to multiply everything in this fraction by 2 root x. All right, so that means that I have 2 root x equals, now if I multiply by 2, the 2's reduce, and then I have 3, and then root x times root x is x, and then I have minus, that would just be 1. All right, so now this equation looks very difficult to solve, but it's actually not really that bad, because if we think about it, this is actually just a quadratic equation. So let me explain what I mean. So let's, on the side, we'll call it, I don't know, some variable a. We're going to let a equal root x. So if we do, then we have 2a equals 3. Well, what is that? Well, if you think about it, if a is root x, then if I square both sides, a squared, that would be x. So then I have 3a squared minus 1. So now this is just a quadratic equation. So I'm going to set it equal to 0, and I'm going to bring the 2a over. So 3a squared minus 2a minus 1. All right, so now I'm going to solve for a. So I'm going to factor 3a and a. And then if I have a minus 1 here and a plus 1 here, let's think. 3a times minus 1 is minus 3a plus 1a. That would get us the minus 2a. So now that means that 3a plus 1 equals 0, or a minus 1 equals 0. So 3a plus 1 equals 0. So subtract 1, divide by 3, a equals negative 1/3. Or over here, a equals 1. Now that sounds great, but the problem said find the x coordinates. So we have to remember that a is equal to root x. So that means that root x equals negative 1/3, or root x equals 1. Now, make sure that you pay attention here. Root x equals negative 1/3. So remember, square root of x equals negative 1/3. The square root of x cannot be a negative value, right? So that means that this does not contribute a solution. But root x could be positive 1, and so x equals 1 if we square both sides. So x equals 1 is the x coordinate of that function where the tangent line is parallel to y equals x plus 3.